topic, but it actually goes right along with the balancing equations that you guys saw in the last video. So we learned how to balance equations, and that was when the formulas were given. However, typically you're not going to see the actual equations written out all nice and neat and pretty. Normally, when you're in the lab, you're going to give just reactants, and it's going to give you the name of the formulas themselves in the lab. And if they give you the name of the formulas, you're going to have to use your nomenclature rules from the last unit in order to write out your equation. After you write out your equation, then you can balance it like we learned in the last video. So looking at the naming rules, it's everything that we learned before. So you're going to have ionic, you're going to have covalent, you're going to have acids. Some of your ionic are going to have transition metals with them. But one of the big things to remember is we use a lot of the Brinkelhoff elements in their elemental state in the lab. So you're going to see a lot of hydrogen reacts with oxygen, and you're going to have to know that if you have hydrogen reacting with oxygen, hydrogen is a part of Brinkelhoff, that diatomic element group. So if you have something that just says hydrogen all by itself, not in another compound, but all by itself, you're going to give it a 2. If you have other single elements, if it says something like magnesium reacts with oxygen, magnesium is not in Brinkelhoff, so you're not actually going to write the 2 with it. You would just write down the plain element symbol. So we have a few examples that we're going to do. And when we do these examples, I have the actual word problems, and we're going to have to write out, using nomenclature, to get us to a balanced chemical reaction. So this one says calcium reacts with oxygen. So with this one, we have calcium reacts with as a plus sign, oxygen. To produce is my arrow, calcium oxide. So I can write my calcium. Let's see if I can. Been struggling with the focus on my document camera, sorry. So we have calcium reacts with oxygen. Now both of those are single elements, and when you write a single element, you're going to have to ask yourself, is this in Brinkelhoff or not? Calcium is not a part of Brinkelhoff, so it's just going to have the Ca. It's not going to have a charge, it's not going to have a number, it's just Ca. Oxygen is a part of Brinkelhoff. So with oxygen being a part of Brinkelhoff, it's going to get a 2. And then it says to produce calcium oxide. Calcium is Ca. Calcium has a +2 charge. Oxide is oxygen with a -2. So +2 and -2, they automatically cancel out. You end up with CaO. Once you have the formulas all written like this is when we need to balance the reaction. And when we go to balance this reaction, I'm going to switch colors so you can see the difference. That's the places that I can put in my numbers to balance out the equation in general. You have to have the same amount of both elements on both sides of the reaction. So I have 2 oxygens here. I need 2 oxygens over here. So 2 times 1 gives me 2 oxygens. Now that also changes my calcium to 2, so I'm going to put a 2 right there. So in order to balance this one out, it will be a 2. There's a ghost number 1 right here, and a 2. If you want to write the number 1, you can. It doesn't matter either way. But that's how you would balance without doing the inventory. I know that I did the inventory for you on all the examples on the other video. I just wanted to show you how to do it without it. In case it's faster for you, or if maybe you're seeing these, you don't have to write out the actual inventory. I'll never ask you for that work. Now the next one that I have here, it says iron plus oxygen. Now this one is another word problem because they're writing out the names instead of the formulas, but this is a shortened method on how to write them out. If you ever have to write one out, you just want to put the plus in the arrow, I am good with that. I say it over and over, chemists are lazy. We want to write things as quickly as possible, so this is the easiest shortcut for that. So we have iron plus oxygen. So with this, we have single elements. We need to ask ourselves, is this a part of Brinkelhoff? Iron is not in Brinkelhoff, so it's just Fe. It doesn't get any symbols. Oxygen is in Brinkelhoff, so it gets a 2. And then we have our arrow. Iron 3 tells me that iron has a +3 charge. Oxide is O, -2. So when I swap and drop, we end up with Fe2O3. Now again, I have to balance my reaction. When I go to balance my reaction, I can only put coefficients in the blanks that I just wrote. You don't have to write the blanks, I'm just showing you what I'm doing. Now, if we want to do this with an inventory or without, it doesn't matter. I'm again going to do this without one because there's only 2 elements and it should go pretty quick. I'm going to save my oxygen for last. So I have 2 iron there. I need 2 iron there. So now looking at my oxygen, they're not balanced because I have 2 here and I have 3 here. With 2 and 3, they're both going to have to go to the same number. So I'm going to have to think about what times 2 and what times 3 can I put them both up to. So if I think about this with my multiplication tables, if I put a 3 right there, 3 times 2 is 6. And 2 times 3 is 6. So oxygens are now balanced with 6 and 6. But that messed up my iron again. My iron, I have 2 times 2 is 4. So I'm going to have to change this number to a 4. This is why it's helpful sometimes to use pencil. But we have a 4, a 3, and a 2 to balance this problem out. The next one, in our last example on these, they have states of matter. You're going to see states of matter occasionally. If it gives you the state of matter, you have to write it in your formula. So here this says solid calcium carbonate. Now when you write it, you're going to have your formula first, and then you're going to have your state of matter after. So this is actually going to go after my calcium carbonate, but it's written before when it's written in the word form. Calcium is +2. Carbonate, ATE, is CO3 -2. So again, the charges are the same, so you're going to end up with CaCO3, and that guy's a solid. Reacts with is my plus. Aqueous, AQ, hydrochloric acid. Hydro means this used to be ide. Acid means that it starts with H, so this one is HCl, and that one was aqueous. 2 yield is my arrow. Solid, calcium chloride. Calcium's +2, chlorine's -1, so you end up with CaCl2, and that one was a solid. We have carbon dioxide, gas. So carbon is 1, dioxide is 2 oxygen, and that one's a gas. Uh-oh, I'm running out of room. I'm going to drop this down here because I ran out of room on my paper. And then I have liquid water. So I have H2O for water, and that's an L. If you have water, you can call water water. I am okay with that. So if you're working in the lab, you don't have to call water dihydrogen monoxide unless you really want to. If you want to get fancy, you can. But you can always just call water water. Now, we have to balance this one out. And we have 5 different components here. So I have 5 different lines that I'm going to draw to balance it out. I'm going to have to kind of squeeze those in. I was trying to sneak in my numbers or my formulas there. Didn't work for me. So to balance this one out, I have calcium and calcium 1 and 1. My carbonate here, CO3, is a polyatomic ion, but I don't have it over here. So I'm going to have to break it up into carbon and oxygen. So I have 1 carbon and 1 carbon. That one's balanced. I save oxygen and hydrogen for last, so I'm going to skip oxygen, I'm going to skip hydrogen, I'm going to go down to here to chlorine. But right here I have 1 chlorine, right here I have 2. I need 2 chlorines on this side. So that changes my chlorine to 2 and 2. But then that changes my hydrogen to 2. But I have 2 right there. And then I just need to check my oxygen because I skipped over that one. I have 3 oxygens here. On this side, I have 2 here and I have 1 here. 2 plus 1 is 3. So that's actually a balanced reaction with just that number 2 in front of my hydrochloric acid. So I hope that that was helpful. If you're ever given the word problems like this, you're going to have to use your nomenclature rules, write your formulas, and then balance it. And then next semester in January, we're going to take word problems like this, and they're going to put numbers in them, and then you're going to have to apply it to some math, which is all algebra-based, called stoichiometry. So we really have to make sure that we can get this part down because this is going to be crucial to our lab and to our math second semester. If you guys have any questions, ask. Otherwise, I hope you have a great day.